For this problem, let's first start with the intercepts. So for intercepts, let's do, actually this one only asks us to find the x-intercept only. So we're just going to find that for this one. First thing we'll do is for the x-intercept, we want to put in a 0 for y. Okay, so if we do that, we have 0 equals 8x minus 9x to the 8/9. Now we have to do some factoring on this. We're going to factor out an x since there's an x in each one. So I'm going to put an x out front here, and then 8x divided by x is going to be 8. So now if we take this next one, we have a minus 9, and we divide this by x, what we're really doing is we're subtracting 1 from the exponent. And again, when we do factoring, it's a form of division. So we're taking this last term and we're dividing it by x. So we really have x to the 8/9 minus 1, and that's going to be x to the minus 1/9. We can always multiply this back through to make sure we did it correctly, but this will be right, 8x, and then we have 9x, and we add 1 to that, it would give us back 8/9. Okay. We can rewrite this as x, or 8 x there, then we have 8 minus 9 over x to the 1/9, just like that. We're going to set both of these equal to 0. So of course, x equals 0 is one of the answers, but we're also going to do 8 minus 9 over x to the 1/9, and we're going to set that equal to 0. We're going to move one of these terms over to the other side, so we can just do, we're going to write this as 8 over 1, and this will be 9 over x to the 1/9. And we want to cross multiply here, so we're going to get 8x to the 1/9 is going to equal 9. We're going to divide both sides by 8, so we get x to the 1/9 equals 9 over 8. In order to be able to get rid of the 1/9 here, we want to raise both sides to the power of 9. We do that because when you raise a power to another power, we multiply the exponents, and that's going to allow us to get this to go away. So we get x equals 9 over 8 to the 9th. And when you do these in the homework, it's going to ask you to round this to the nearest 10th. So if we put this into the calculator, we should get about 2.9. So we have our x-intercepts. Our x-intercepts down here are going to be 0 and 2.9. So we have those answered. So now let's go ahead and continue with the finding critical numbers. Okay, so if we find critical numbers here, we want to set the original problem equal, the derivative, we want to set equal to 0. So let's first find the derivative. It's going to be 8 minus, and if we bring the 8/9 times 9, we're going to get another 8x. Subtract 1 from the exponent, and that's negative 1/9. We can rewrite this as 8 minus 8 over x to the 1/9. That is our first derivative. Now, one thing we're going to notice right away here is that 0 makes the derivative undefined. So remember, when we're finding critical numbers, there's two things we look at. First, we look at where the derivative is undefined, and that's going to give us one of our critical numbers, 0. The other way we find critical numbers is by setting the first derivative equal to 0. So we're going to continue with that. So we have 0 equals 8 minus 8 over x to the 1/9. We're going to move one of these terms over to the other side. 8 over x to the 1/9 is going to equal 8 over 1. We're going to cross multiply like we did earlier for the intercepts. So we're going to multiply that. We get 8x to the 1/9 equals 8. If we cross multiply there, divide both sides by 8, and we get x to the 1/9 equals 1. Now we're going to do the same thing that we did before for the x-intercept. We're going to raise both things to the power of 9. So if we do that, we get x is equal to 1, and that would be our other critical number. So we have 0 and 1 so far for critical numbers. Okay, so now we're going to do the number line. Let's do that here. Y primed number line. We have a 0 and we have a 1 here. We want to put in our test numbers. We can use -1. Let's use 0.5. And we're also going to use a 2. We're going to put these into the first derivative. So again, we want to use this one right here. So if I put that in there, I get 8 minus 8 over. Now the ninth root of -1 is actually going to be -1 there. And so when we subtract that, we're going to get 8 minus a -8. So that's going to be plus for that. And we're going to do the same thing for these other ones. We can use a calculator. If you put 0.5 in there and do a calculator, we're actually going to end up getting something negative there. And then if you put in a 2 into this, we're going to get something that is positive. So again, just use your calculator to put that into here. And that's going to give you these signs. So from that, we can do the increasing. Increasing is going to be -infinity to 0. And then from 1 to infinity. Decreasing is going to be from 0 to 1. So we have those. Now, let's look for if we have a relative max on here. We do. This is increasing, and this is decreasing. This is decreasing, and this is increasing. So it looks like we have a relative max at 0. And we have a relative min at 1. By the way, something I didn't mention earlier, when we did the critical numbers up here, we got 0 and 1 for the critical numbers. Now, 0, although it makes the first derivative undefined, we can put 0 back into here, which is what we're going to be doing now. And by putting that back into here, that does give us a point that's on there. So if we tried to find the relative max here and we ended up getting something that's undefined, then we know that that couldn't be a relative max. So 0, we can put in here and 0 for both of those. We're just going to get a 0 for the relative max. And then for the relative min, we put 1 into each of these. We get 8 minus 9. That's going to be -1 we put in there. And so that is going to be the relative min. Okay, so we use first derivative for that. Now, the next thing is we want to find the Hilbert numbers in concavity. We need to use the second derivative. So our first derivative was 8 minus 8x to the -1/3. That was our first derivative. Well, this is not 1/9. I meant to put here 1/9. Okay, then now y double prime now. We're going to take derivative. 8 is 0. Now this, the 1/9 is going to come down at this negative and negative. That'll be positive 8/9 x. And that's going to be, if you subtract 1 from there, that's going to be -10/9. We can also write this as 8 over 9 x to the 10 over 9. What we notice about this is that 0 is going to make the second derivative undefined, which means that's going to be one of our Hilbert numbers. Okay, so we'll get a 0 for that. The other way that we find Hilbert numbers is by setting the second derivative equal to 0. So we're going to do 0 equals 8 over 9 x to the 10/9. We can do 0 over 1 here. With these kind of problems, again, we're going to cross multiply. However, this time we don't get any x's to solve for, because if we cross multiply these diagonals, 0 times anything is 0, and we get 8 going the other way, we get a false statement. Now, because we get a false statement there, that means that this is not going to give us any Hilbert numbers. So the only Hilbert number is 0, and that's where the second derivative is undefined. So when we do our second derivative number line, we're just going to have a 0 on there. That's the only Hilbert number we have. We're going to test -1 and +1. We can put into the second derivative. So we're using this one here. Okay, so if I put this in here, I'm just going to give you the result of these signs. When we put that in, we're actually going to get both of them are going to end up being positive when you put that in. Okay, so negative 1 to the 10 ninth is a positive 1, and a 1 that's positive as well. So that's why we get two positive results. By the way, the reason why that is positive, you can think of this as we're taking x to the 10th power, and then we're taking the ninth root of it. So negative 1 to the 10th power would be something positive, and if we take the ninth root of it, then it's still positive. So that's the reason why we get a plus here. All right, so from that, we actually have concave up for everything here. So concave up is actually going to be now one thing we want to be careful about on this one. Now, I've mentioned before that for concavity, we don't have to separate it. Now, there is one exception to where you do want to actually separate this, and we are going to do so on this particular problem. We're going to do this because the first derivative or second derivative was undefined at 0. Whenever we get a second derivative that is undefined at some number, that number we're not allowed to include with concavity. That really is the only case where we're ever going to not include the number for concavity. And that's, again, when the second derivative is undefined. Undefined at 0 means we are going to exclude that. So we have to break this up and go negative infinity to 0, and then from 0 to infinity. Again, that's the only time we ever have to do that. Okay. Concave down is actually going to be D and E. We don't have any places where it's concave down from our picture. It's always going to be concave up here from our number line. And also, we see that inflection points are also going to be D and E here because we don't have a plus going to minus or minus going to a plus. We don't have any concavity change that's there. All right, so now let's go ahead and put all this information together and graph. First of all, we do have these critical numbers at 0 and 1. Okay, so 0 and 1, we're going to put here and here. Okay, so 0 and actually, those are critical numbers. Got to look at x-intercepts. So let's do these here. This is what I meant to put. 0 and about 2.9, that's about 3. So we can just put our dot right there. So that's our x-intercepts, 0 and 2.9. Okay. We have another point, 1, -1, and 1, -1. We got that. That was our relative minimum, 1, -1. Okay. So now we want to use our increasing, decreasing, and concavity in order to fill in the details. We are increasing from negative infinity to 0, and we are also concave up throughout. So first of all, I need to draw a line that is both concave up and increasing up to 0. We can just do something like this. That would be increasing, and also we're bending it this way, so that way it's concave up. Now, it's still concave up throughout. We do see that from our decreasing from 0 to 1, and it's also going to be concave up. So next thing is we have to draw this from like this. There is going to be a cusp here. So there is a sharp corner at 0, 0 for this particular graph. Again, so it's decreasing between 0 and 1. And also if we go back up here, it's increasing again from 1 to infinity. Increasing from 1 to infinity and concave up means it's going to go through there. So we did need to find that x-intercept, so that way we know where the graph crosses here. And that is going to be our final answer.